Euclid's Elements, Book 1, Prop 42. To construct in a given rectilineal angle a parallelogram equal to a given triangle. So we have two givens here. We have a triangle, ABC, and let's have a given angle, call this angle D. So we're supposed to construct a parallelogram using this angle that is equal to our given triangle. So that's our goal. So the first thing we're going to do, and let's keep track of here what we're do and our y. The first thing we're going to do is bisect BC. So we can bisect BC at point E here because we can bisect any given straight line using prop 10. So we're going to create BE equal here to EC. And that's going to give us two equal bases here, or two equal lines. And then we're going to connect A and E, which we do from prop 1. Postulate 1 allows us to connect any two straight lines. Next, we're going to use prop 23, which allows us on any straight line at a given point on that line to construct an angle equal to a given rectilineal angle. So on line CE at point E, we're going to construct an angle equal to our given angle D. So we're going to create CE, and we'll just call this point H here. And we'll extend that as far as we wish. So we have made angle CEH equal to angle D. We also know, using prop 31, we can, at any given point, make a line parallel to a given line. So we can make a line parallel to BC at A. And we'll just extend that as far as we wish, and we'll call that GH. So we're going to make AG parallel to BC. So this is going to be parallel to this. Likewise, using that same prop 31, at point E, we can make a line parallel to EH. And it will look like this. So we're going to make, CG equal here to EH. Not equal, I can't keep saying it, parallel. So we're going to create CG parallel to EH. Again, prop 31. Now we can pretty readily see that this figure here, this quadrilateral, is a parallelogram because it's composed of two sets of parallel sides. So we've created parallelogram ECGH. Now let's take a closer look here at triangle ABC. Triangle ABC is composed of two other triangles here. We'll do this triangle here in, say, green. So it's composed of this triangle in green. So triangle ABE. Plus it's composed of this triangle here in red. And these triangles are equal, as we'll show in just a second, AEC. They're equal because, according to prop 38, they're on equal bases and they're contained in the same parallels. So there's the parallels, and that contains both these triangles, and they're both on equal bases. Therefore, they're equal to each other. So we could say that triangle ABC, the whole composed out of these parts, is equal to two of these two things, or it's equal to, since these are equal to each other, it's equal to two greens, it's also equal to two reds. So let's say triangle ABC is equal to double triangle AEC, because it's made up of both of those, so two of those. Now let's take a look at our parallelogram ECGH, which I'm going to highlight here in blue. And when we look at this blue parallelogram and the red triangle, we should note that they're both on the same base and contained in the same parallels. So according to prop 41, triangles that are on the same bases and in the same, a parallelogram that's on the same base with a triangle and in the same parallels, that parallelogram is going to be double the sides of the triangle. So parallelogram ECGH is equal to double triangle AEC. But we see that triangle ABC is also equal to double AEC. And so if two things are equal to the same thing, then they're equal to each other. Common notion one. Therefore, parallelogram ECGH is equal to triangle ABC. And we built parallelogram ECGH in an angle, CEH, that was equal to the angle at D. And that's what we were supposed to do. Therefore, given a rectilineal angle, we can construct a parallelogram equal to a given triangle, which we did. We constructed parallelogram ECGH, which was built in this angle equal to D, equal to triangle ABC. Since that's a construction proof, we conclude this with QEF.